Okay, picking up where we left off yesterday, when we were using our definition of it, the limit definition of the derivative, and finding the slope, or estimating derivatives of a function at a point. Okay, so finding the slope of the tangent line. Now, part A we did yesterday, and it was using I think they call it the alternate form is what they're calling it in here, right? The alternate form of the definition of the derivative. Part B is more using, it still says the a plus h, so it falls into the alternate form, but it's more the definition of the derivative, if you ask me. So, oh, and don't forget, what is our function? If you go back up to the beginning, I need it for reference. It's y equals 2 over x at x equals 3, right? Okay, so the limit as h approaches 0 of f of a plus h minus f of a. Here we go. Limit as h approaches 0. What about f of a plus h? Every place I see x in the function, I'm replacing it with a plus h, so 2 over a plus h minus f of a. So instead of 2 over x, we're going to have 2 over a all over h. Okay. I feel like, unless I'm mistaken, just thinking about what I was working on the other day, I feel like we did one like this in the last lesson where we have the h on the bottom. What I'm going to do is I'm going to pull the h out front, and I'm going to take these two fractions on top and combine them into one fraction. Did we do that already? We did that the other day? Sounds okay. So you're not going to totally be wondering what I'm doing. So limit is h over 0. Because it's going to be fractions within fractions, just easier to take that denominator of h, think about just a 1 on top, and we can factor it out as a 1 plus h. And not the only way we have to do this, but it's an option. Now, my others, 2, shoot. So, should I stop now and fix it now? This is, yeah, should we put the 3 in? This is the problem with taking a break. Like, yesterday I was in the groove. I had the 3 in. Did you guys already maybe put the 3 in without me? If so, awesome. Stop me, ask me, because... Okay. I did forget. Totally forgot what I was doing until I just looked at my notes. It says when x equals 3, right? So that is our a value. So with that in mind, let's see. Can I get these a's changed out? Probably not easily. Yep, I'm going to have to. So these a's are going to be 3's, right? Okay, sorry guys. Okay. Now, 2 over 3 plus h minus 2 over 3. So if we think about my common denominator is going to be multiplying the two denominators. So I'm going to say 3 times 3 plus h is my denominators. It's just multiplying the two denominators. If we just multiply the two denominators, then you can kind of do the cross products thing. So first numerator times the other denominator. 2 times 3 is going to be 6. This is subtraction, so minus. And then it's going to be 2 times 3 plus h. Okay, are we better? It'll be nicer to work with the 3 anyways. The limit as h approaches 0. I'm still leaving the 1 over h out front until I'm more cleaned up. On top, I see what? 6 minus 6 minus 2h. Still over 3 times 3 plus h. 6 minus 6 is canceling. I only have negative 2h left on top. How do you feel? Can I go ahead and do my next canceling? This is what you would see in the answer key. I should go ahead and probably do the next canceling. In that if I only have negative 2h left, what can I do? I can cancel the h. That's only because I only have the 2h left, right? So at that point, you're going to be left with the -2. I probably should have just written that out as a second step, but limit as h approaches 0 of -2 over 3 times 3 plus h. At this point, so we no longer have h in the top and bottom, so we can go ahead and direct substitute. So h is going to become 0. And I have -2 over 3 times 3, which is -2/9. Okay. Slope of the tangent line, right? Some of the things you're doing in homework are, for instance, slope of the tangent line. And then they might ask you to write the equation of the tangent line. Okay? If you're writing the equation of the tangent line, here's your slope, yes, -2/9. And then what would be our point? Well, if they provide you x is 3, can you find the other half of the point? Yeah, because you would put 3 into the original equation, it was 2 over 3. And then real quick, normal. What about the normal line? What's the only difference with the normal line? Opposite reciprocal. Instead of -2/9, it's +9/2 for your slope. Yes?
So were we supposed to get the same answer for?
Yes.
Does that mean anything?
Okay, so the question was, were we supposed to get the same answer for both part A and part B? And yes, we are supposed to get the same answer because both of these are forms of the derivative. Okay? And the derivative of a function is not a changing thing. It is always a consistent thing. So the function y equals 2 over x is always going to have a specific derivative, which, you know, we'll talk about later, but so at point 3, it's always the same. It's -2/9. So on that curve, the slope when x equals 3 is -2/9. The slope of the tangent line, that is. Okay? Does that answer the question? Okay. At the bottom, this is just a little bit of what I would call interchangeable vocabulary. Okay? We're finding all the following. We're finding the slope of the tangent line, also called instantaneous rate of change, also called the derivative, also called limit of the difference quotient. This is what it's just interchangeable vocabulary, all equivalent. Okay, so all of those guys are interchangeable vocabulary. Okay, ready for the next page? Forgot about this page. Officially, it says grab some colored pencils and a ruler. Colored pencils are just basically two different colors. One is going to represent length, one is going to represent slope. They say blue and red. I don't know that I honestly ever used the actual ruler here on this particular example. So, I don't know if anyone actually wants colored pencils or not. Oh, my daughter did leave them in here. I would just say, you know, you can use two different colors. You know, I don't even know what's in here or what works, but you can just use two different colors in code. I mean, honestly, I'm not even sure how much. I don't know what's in there and what works. You know, that's kind of the desk stash of when one of my kids is in my room before or after school and they need colored pencils. So, you know, pencils, pens, whatever floats your boat, right?
That's your favorite color? You like to make red a lot.
Okay.
Orange and pink are my favorite colors. More so or ellipsis. I like people on distance and returning.
I mean, all you have to do is, as a blue for me represents length, change your color, right? Red represents slope. That's what it tells me to use. So, or you know what? Just do it all in pencil if you want. You know, it's your call. It's not going to be the end of the world if you don't change colors up. So, I don't know how many of them are actually sharpened decently, but I hate sharpening colored pencils. So. Okay, so the graph y equals f of x. You will notice in calculus, they always are naming the graphs. They don't just put a graph here. They're going to tell you the name of it. That way you know what graph they're referring to. And it is differentiable on the interval from a to a plus h. So the graph being this curve. And it's saying it is differentiable on that interval. So you can take the derivative. Now, we're going to use the expression in column 1. So we have 1 through 7 here. And we're going to do two things with it. We're going to talk about whether that expression represents a length or a slope. And then we're going to draw the geometric representation up here. So drawing in the length or the slope. And then we're going to talk terminology over here. Okay? So we'll use blue if it's a length, red if it's a slope. So, f of a. What does f of a mean? Not slope.
Length. Derivative.
But see, I would put slope and derivative into the same category.
All of the above.
Okay, let me ask this. What does f of a represent on this graph? The y value, right? So, in other words, if this is a, right, then the f of a is the y value, correct? Oh, I should have thought about, oh well, I shouldn't be using one of the colors yet, because that's not, I haven't really thought length, we haven't talked about whether it's a length or a slope. But the idea here is that f of a is this piece right here, yes? It is the height of this point. And if it's the height of the point, is a length or a slope? And it's a length, right? Because slope is going to be some kind of rate of change. And so, yeah, I was going to say. So the idea, I'm going to change this to blue here. That, that in my mind, when you have a, the y value is f of a. Now, with that in mind, so where is f of a? And f of a, one way we could denote it is right there. It is the height at a from the x-axis up into that point. And so I'm going to label that a 1, that way just kind of associating that it goes with problem 1. And terminology, okay, Connor said y value. Another way to say it would be the value of f when x equals 3. Okay, so value of f at x equals 3, or we could say y value when x equals 3. Same, those are equivalent in my brain. Okay? Okay. When you're ready, start thinking about f of a plus h. You don't have to go to length or slope yet, but just what does f of a plus h represent? If here's a, and f of a is the y value, or the height when x is a, what's over here? This is a plus h. So what's f of a plus h? F of a plus h is going to be the y value over here, the y value when x is a plus h. And if that's the case, what is this? Is this a length or a slope? It's another length, isn't it? Where is that length? Where can I draw in something that represents this length? In other words, where can I draw in something representing the y value f of a plus h? And that is the height right there, the height of that point. I'm going to put a 2 on this because it goes with problem 2. So again, this is a length. And if we go with similar terminology to last time, it's the y value, or it's the value of f at x equals a plus h. Why did I say 3 last time? I wrote 3. Did I say 3 also?
Yeah.
Yeah.
Why?
I don't know.
I don't know, but I believed it.
I didn't question it.
Is there a 3 on this page? Other than question number 3, is there a 3 in this problem? What?
No.
All I can think of is it was 3 on the last page. I don't know, guys. I don't have a good answer.
Oh my goodness.
The desk lean back. It's the desk lean back.
Megan's throwing things. They're doing something weird back here. Okay, so this 3, where I wrote 3, it's actually A. Don't ask me what I was thinking.
What were you thinking?
I said don't ask, because I don't know. I don't have a good answer, okay? Okay. Okay.
I was just trying to crack you back, but I just.
Is that what that was? See, I have my back turned, so I didn't even get to see it. I just heard it. Like, man, Megan's mad about that. Making lots of ruckus. Okay. Number 3. F of a plus h minus f of a.
It's like the line between those 2 points.
Okay, so the line between the distance between those two, right? So it's going to be the distance between the f of a plus h and the f of a. And so if it's the distance between those, again, we are going to talk length, right? Now, we could do it either over here in the terms, it's the distance between f of a and f of a plus h, or we can look over here in that, I'm going to kind of do it off the graph, but we have this height here and this height here. Does that make sense? Like this is the height of f of a, this is the height of f of a plus h, so the difference between them is that distance there. Which here I get to legitimately use a 3. Because we're on question number 3. I'm just labeling it question number 3. So this again is a length. And we talked about the difference, right? It's the difference between the two. So the difference in y values for f between x equals a and x equals a plus h. So I'm going to use the word difference since it's subtraction. Difference between y values of f. I should have said, okay, make it work. Difference between y values of f. I'm going to use the word between again. I'm getting wordy. Between x equals a and x equals a plus h. Think about the next one when you're writing. I know a lot of you are still writing. or is h? What are your thoughts on h? It's what? It's a length? Where is this length? The distance from A to A plus H. Okay. So it is a length. And it's labeled right here, isn't it? I was going to show it down here. But it's the difference from A to A plus H. It's the difference, or we can use the word displacement as well. But it's the distance on the x-axis between A and A plus H. So displacement, distance on x-axis between A and A plus H. Number 5, f of A plus H minus f of A all over H. What are your thoughts? Slope? Do I dare ask why? Okay, it looks like one of our equations for slope. Valid answer. Okay, okay, go back to algebraically when we did slope. Slope is the what? Something over something, rise over run. We're doing y minus y over x minus x, right? We call it a rate of change. Well, think about this. F of A plus H minus F of A. And if you remember, we looked at one point that this H is actually A plus H minus A, isn't it? And so that just becomes H. So this is essentially slope, which means I need to change colors and quit using blue. Because it's a slope. Now, where is this slope on the picture? It's a slope between what points? A plus H and A. And so really it's that slope that's already drawn in, isn't it? It's going from here to here, right? So I'm going to call that number 5. In this, because well, I won't say that. In this, it's the slope between two lines. It's the slope of there's not a tangent line there, but a secant line. So this is also average rate of change. So when we talk about the terminology, it is the average rate of change, AROC, on F. It is also the secant line slope. It is a secant line because it is a line drawn through point A, the point at A, and the point at A plus H. It's not just a line drawn tangent to the curve.
So it's like there's a point on the curve.
Right. Okay, 6. Limit as h approaches 0 of f of A plus H minus f of A all over H. What is that? It's a slope, yes. That is our formula for derivative. And derivative is the slope of the tangent line, right? So it's definitely a slope. Because it is the slope of the point at the tangent line, this is our instantaneous rate of change. Okay, so this is our IROC. Okay, it's our IROC, and this is the slope of the tangent line. You could also call it f prime of x, but it is slope of the tangent line. Now, how did I draw this in? Okay. And this is the slope at what point? What point are we talking about here? And it's that A. Because that A is where you can fill the number in, right? So it's going to be the slope at A. So point A is right here. My curve is this curve, this increasing curve here. I don't know if I can do this justice. But the slope of the tangent line, there's your tangent line drawn at A. That's my attempt at least. The graph is getting kind of messy, so it's kind of hard to see that. But I tried to draw a tangent line because my curve is increasing upward. My tangent line is below it. And one more to consider when you're ready. Number 7 is f prime of A. What is that notation for? Slope, because that's derivative, right? That's saying the derivative of f at point A. So again, this is slope. The slope where? Slope of the tangent line at point A. Didn't we just do that? This is just another way to express number 6. F prime of A is derivative. This is definition of derivative. So I'm actually just going to write the same as number 6. Okay, now I have one last page, right? 24 hours from yesterday at this time when I thought I had one last page. I actually do have one last page. And this...
I was glad you didn't.
You're just glad you didn't have the homework last night.
Yes.
I understand.
We're reading for you, but we're also reading against
I know. Well, you know, it was a busy night because my family was all at that game too that went
We
forever.
also had our stupid physics lab to figure out that.
Ah, so you had physics then, okay. Which I know physics, you guys have a test next Tuesday or Wednesday.
We do.
Yeah.
It's Tuesday.
And I say that because he came to me yesterday and said, "You won't be doing a test next Tuesday or Wednesday, will you?" I said, "No. We'll be maybe quizzing at the end of the week. Beginning of the following week." And that's, like, I don't have my lesson plans. Like, that was just me on the fly at lunch yesterday when he caught me, so. But that his comment was Tuesday, I think Tuesday or Wednesday. So, okay. Understanding the derivative symbolically. These are problems, and we can't necessarily find the limit as they are. If you try and find the limit as they are, they're probably going to be an indeterminate form of 0 over 0. That would, just without even doing any of the work, that's probably what's going to happen. Now, with that in mind, eventually what it is, these are all forms of the derivative. These are all definition of derivative, where they're saying, okay, here's the definition of the derivative of some function at some point. Well, if you can identify what your function is, so like what f of x is, and if you can identify at what point they're asking it, you don't have to do this limit. You can use these shortcuts we haven't learned yet to do the derivative at that point. Okay? So our job right here is going to be to attempt to identify what f of x is, so what function is being represented, and at what point. Okay, so like if I go back real quick to where we started today. Is this where we started? Yes. If I go back to this problem, or even the problem above it, what we're trying to identify is this information right here. Okay? We're trying to identify, like, as we look at this derivative or this limit, what function is represented and what x value is represented. Now, as you, let me bounce back. So, they ask us, let's see. So we need to find y equals f of x. Now, be flexible. Instead of an a value, they're calling it a c value. Same idea, right? Be flexible. Don't get hold up on, no, it has to be a. They'll randomly change things. So we're identifying the function and the value. Now, when I was doing this on my own, trying to think, okay, how am I going to explain this to you guys? Because that's what, I can see it. Although some of these were tough, and I had to look to see it, but now how do I get it to you guys? One thing that helped me is I wrote out the basic form of the limit. Which limit form is this? This is the one that's the limit as h approaches 0. Notice it has h on bottom. What is that? That is f of a plus h. Actually, I shouldn't be using, should I use c here instead? Yeah. I'm just going to f of a plus h. I'll use that. But a could be an a, it could be a c, it could be an x. So compare this form to this, to what I just wrote. With that in mind, we want to know what our function is and what our, quote, c value is, which, if you prefer, you can think of it as a. Any thoughts? And then my thought would be compare this, on this one at least, compare this h plus 4 to this f of a plus h. What's your thought? Huh? For what? F of x is not just 2, it has to be a function. It's like something that we could plug an x value into. This is where I think once we start seeing it, it'll be better, but. Mm-hmm. What? No. Just square root of x. Now, okay, give it a moment to click here. If this is square root of x, okay, if that is my function, this is where you kind of do trial and error. That's what that's what I kind of do, is I think through trial. If this is square root of x, how does a plus h work? That means every place I see an x, I'm going to put in here a plus h. So my first thing would be square root of a plus h. Except the other part of this is I also need to find a. What would be my a value then? Not 2, 4. Now, don't get hung up on the minus 2 at the end. I haven't dealt with that yet. Okay? Think about this. The square root of a plus h is the first piece. Okay, so h is there, 4 is representing my a value. Now, and then it's going to be minus f of a. So that's going to be minus the square root, but what number do I put in the square root? 4, and the square root of 4 is 2. Maybe? Now the key is to be able to do this on your own, right? Without your classmates telling you, oh, I think it might be this. Are we seeing this one at least? And this is where I would say, don't be afraid to, okay, I'm going to grab a piece of scrap paper, I'm going to write this out. Okay, if I think it's this, limit as h approaches 0, square root of a plus h, so if I'm saying it's 4, I'd say 4 plus h, minus the square root of x, but I'm putting 4 in, so square root of 4 all over h. Does that match what we were given? And it does once you mix things around, yes? Okay, that's what we're doing on all of these guys. You'll get a feel for it. It just takes time. Okay, so next one. We need to know f of x, and we need to know our c value, or our a value, whatever you want to call it. I keep calling it a because I'm so used to it, but c is a common one to see as well. Now notice, we're in the same original derivative form that we just used, right? So it's the f of a plus h minus f of a all over h. And I know that because it's h approaches 0 and it's h in the denominator. Okay, thoughts? Wanna try it, Jacob?
I think it's e to the cosine x.
Play around with it, see if it works, right? So if he says it's e to the cosine x, for the first part, this is supposed to be f of a plus h. E to the cosine of a plus h. Well, it's pi plus h, so what's that telling me then? A is pi. Now, where's your big checkpoint? E to the negative 1. Does it make sense there? So if this is e to the cosine x, but it's f of a, so it's e to the cosine of, what are we saying a is? Pi. What's the cosine of pi? See, for me, this is what I do. I know you guys probably do unit circle, but the cosine of pi is, whoops, negative 1. So does it work? It does. Okay? Okay. Try another one. Are we using the same form? It's still h approaches 0. There's still an h in the denominator, yes? So we're using that same form that we talked about on the past two. Guesses? Huh? Where's your variable? Tangent 2x. We were all sold that the tangent was there, right? That wasn't the issue. There's a tangent there. We got that. So this is tangent to 2 plus h. So what is that 2 plus h? That's my a plus h, isn't it? So what is my a or my c value? 2. Now, to confirm, I'm always at least mentally checking, does that make sense? It says tangent of 4. That's the problem. It's already simplified here, isn't it? So you don't get any help here. But if it's tangent of, or f of a, so tangent of 2, plug in the 2, 2 times 2 is 4. Okay. Are we still using the same form on D? There's h approaches 0, yes? Do we have the 1 over h? Or do we have the h in the denominator? I ruined it. We do have the h in the denominator here, don't we? I struggled with this one, I'll be honest. Took me a bit to see it. And because really if you put that h back in the denominator, it's h there, and then it's up here, ln of 6 plus h over 6. Okay, so there is h approaches 0, h in the denominator. On top is supposed to be f of a plus h minus f of a. We're trying to be tricky. Really tricky. Thoughts?
ln
There's an ln involved, exactly.
x over 6.
No, you're going too far with it.
X.
Because here's the idea, guys. Remember, you have to have f of a plus h minus f of a all in that right there. Right? Because there is nothing else left. Do you remember your natural log rules? Division within a log is subtraction of two separate logs. So this is really natural log of 6 plus h minus natural log of 6. If I write it like this, can you see it? Now it's pretty obvious, isn't it? Yeah. F is going to be natural log of x, and my a or c value is going to be 6. Wow. I'm glad you guys are following along, because I look back at this, and this just looks like a disaster right now, but it makes sense when I write it. Okay. What do you notice about E and F?
Yeah.
It's not h approaches 0, is it? It's not h in the denominator. This is that other form. This is that alternate form. So I'm going to write it here so we have it beside us. This is the limit as x approaches a of f of x minus f of a all over x minus a. We're still doing the same thing though. We're trying to find f of x, and we're trying to find our c or a value. In my opinion, these are easier once you figure them out. The information is more obvious. Thoughts? Not obvious yet?
C.
Huh?
A3.
Is A3? Yep. How do we know that so obviously? The bottom says x minus 3, and the limit says as x approaches 3, and that is my a value. Okay, that's one reason it's obvious. I need f of x. What's it say here? The limit of f of x minus f of a. Do you see f of x then? Uh-huh. It's the x minus 1 squared. And my guess is what's tricking you up is the fact that it's only a minus 4. But that minus 4 is what you get once you plug 4 into the equation. Because remember, f of a here, or not 4, 3. So in this case, it would be a 3, and a 3 here, yes, in this problem? And so f of 3, well, what is 3 when I plug, what is this equation when I plug it into 3? 3 minus 1 is 2, 2 squared is 4. Does minus 4 make sense? Yes. Okay, I feel like I'm having some success. We'll see how it goes when you go look on your own, but I see success. I see recognition. Okay. This one is the same form we just did, right? Need a function and a c value. She stole the easy part. C is negative 2. Because it's the limit as x approaches negative 2. Even though the denominator says x plus 2. Well, that makes sense because it's x minus negative 2, right? Cube root of x minus 6. And I know what I do is I then, okay, let's see, does this cube root of -8 thing make sense? If I plug in -2 minus 6 is -8, cube root of -8. Yes, that makes sense. Okay. Now they really could have just said cube root of -8 is -2. So they really could have just said +2 here, but they didn't. So, okay, I am done now, right? Okay. And the bell's not totally ringing and kicking us out. Okay, guys. Work through the homework for Monday. It's decently long. It is. It's 25 to 30 questions. Somewhere in there. Is it 25? I can't remember if there's something after 25 or not.
I mean,
So, yeah.
there's like
Yeah. Real quick, I'm trying to think. Are there any, what hints do I need to give? I already talked about, I will say on that first page, you'll notice that 1, 3, and 5 to go together, 2, 4, and 6 go together. So, like 1 and 2, you're finding the derivative. And then 3 and 4, you find the equation of the tangent line. And then you're doing the normal line. I'm trying to think. Things that on 13, when you're filling in that chart, you will notice like they ask you what kind of point it is and what's going on, whether the graph is increasing, decreasing, it's a max, a min. When it says estimated slope of the tangent line, it says something about grabbing a ruler, doesn't it? Maybe it doesn't say grabbing a ruler on this part, but I did. But it is drawing your tangent line in and doing your rise over run. Kind of like what you guys had to do at the beginning of the homework the other day, right? Draw in tangent lines where necessary, go back to algebra 1 and do your rise over run. Okay? So, yeah. The only other part, on 14 through 18, they give you a table of values, right? AP Calc loves tables of values. Loves them. Okay, find a numeric derivative from a table of values at a point can be estimated by finding the slope of the secant line through 2 points on the graph at either side of the point. So like on 14, if you're trying to estimate the derivative at -2, then you're using the -3, 4 point and the -1, 2 point. Does that make sense? And that's what it's indicating the directions. That in order to find the slope of the secant line, you use a point on either side. So using a point on either side. Honestly, I might go ahead and put the answer key up. I haven't decided what I want to do there. I have a feeling it's helpful, isn't it? You have that answer key to be able to kind of check pieces. Yes. Yes. I'm going to stop this.